it makes it even smaller. I need it further back.
You want a book or something?
Maybe that might help a little bit. No, it's okay. It's okay.
You sure?
Trust me, I'll look at that better in a minute. Where's that list of names? Are we finished with it? The list of names? No, still going around. Okay. Don't worry, you'll see. There we go. I'll write big for you. So here's my email address. So for the people who are having trouble logging in, well, for everybody you need my email address.
I think they gave us your email with the rest of the teachers.
Did they? Oh, good. Okay. Well, just in case. No, that other guy, Stephen B. Yes. I'm Stephen the original. I was here before him. So again, apologies for the screen size. It's ridiculously small. I know. If you can't see, please move up to the front. Okay. Or if you prefer to play it cool down the back, that's okay, as long as you write down what you can see. Now, we didn't have induction last week because of the bus strike, so I won't spend too much time talking about it because I want to get started on the class. And what you need to know, well, it's a 2-semester course. At the end of both semesters, there's an exam. At the end of semester 1, there is an exam worth 10%. Oh, they've changed it. Yeah, so for semester 1, you have coursework, which is 10%. So for semester 1, you have a coursework, which is worth 10%. Then you have an end of semester 1 exam, that's also 10%. Then you have a second coursework in semester 2, that's 10%. And then the final exam is 70%. So as you can see, a lot of marks for the final exam. This is probably the same story for biology and chemistry and the other subjects, okay? What's this here? Oh, good, you got this?
Yep.
Oh, sure, I'll stop talking now. Right, so for topics, you're all science students, so your semester 1 will be basic sort of algebra, trigonometry, things like this. And in semester 2, you'll do calculus and statistics and things like that. So the science course, there's a mix of topics in science. The engineering students do more calculus, the business students do more statistics, whereas the science students do a little bit of both, a little bit of statistics and of calculus, okay? So look, maths. Some people here are going to fail. I know this because I've been doing it for 9 years. And the reason people fail, what do you think?
Because it's hard.
Nope. It is hard, but this isn't the reason people fail. What are we saying? No practice. Practice is key. So if you don't practice the questions, if you don't do your homework, then you will fail. If you practice and do your homework, then you succeed. Simple. So your ability to pass or fail, that's left up to you to decide. Like I said, I've been doing this nearly 9 years, and I learned that I cannot make students work. I can't. It's impossible. You'll either decide to work or not work. So if you decide to work, I'm here to help. I'm happy to see you in the office if you have questions, or if you need to email me or whatever. If you don't decide to work, then I can't help you, and that's your problem, not mine, okay? So maths, I know it's going to be difficult for some people, but as long as you stay on top of the work, then you'll be fine. I should also say all the lessons are recorded. The lessons will be put up on YouTube as well. So even if you miss a lesson, you can still see the lesson since it's recorded, okay? For this lesson, you get worksheets, 1 worksheet per class. All these worksheets are on Moodle as well, except for today I printed the first worksheet because I'm not sure if everyone can log in. So we're going to start off with algebra first, something I'm sure you've all seen before. So we'll start anyways. For now you just need pen, paper and a calculator. Although if you don't have a calculator just yet, that's okay, you'll need one soon. Pen and paper is the minimum for today.
We were trying to tell us what calculator.
Yes, if you want to go buy a calculator, The best one for this course is Casio 991. It's the best for maths, physics.
How much is it? I have one, but I don't know.
Yes, that's why I don't like this one.
Good.
This is the Casio 991. Some people have this calculator already. This is the Casio 991 here.
Would the FX 100 be okay?
I think the FX100 just has slightly less features, but it'll be fine.
The 150 would be okay?
Yeah. This is the best one though, because it has all the features. Those other versions don't have some of the features which you'll find useful for the class. There's no rush, you know. I mean,
Be able to buy that.
yeah, you can get these in Eason's bookstore on O'Connell Street, or Argus, or other bookshops. I mean, your best place in Ireland to find calculators in a bookshop. So if you're walking in town and you see a big bookshop, have a look at the calculators, you can see if they're there. Sometimes students can't find it in a bookshop and they have to order it online on Amazon. Price between 20 and 29 euros depending on where you get it, okay? Where's this? For this one? Okay, well that sounds like the best price. Now that might be a slightly different version, yeah, but that sounds fine too. That sounds fine. Yes?
There's also like you can find a calculator in Spar. Yeah, across the street.
Is it Sharp? The calculator brand? Okay, well anyways, it doesn't matter too much. That's the best one, but at least the Casio. Casios are easier to use than Sharp. I don't know which one it is in Spar, do you know?
It was around 20 euros, but we didn't see it.
Yeah. Anyways, if you have a Casio, that's fine too. And if you have a graphing calculator, just need to know how to use it. If you don't know how to use it, buy a new calculator. That would be the easiest thing.
This is more expensive. You can't I bought like 50.
Oh, trust me, it's worth the investment when you're in the exam and you have an easier to use calculator. Yes, yes, it'll be worth it.
Use graphic calculators.
You can use it, but we don't need to use it. But if you have one and you know how to use it, that's fine. That's fine. Okay. Linear equations. It's so bright in here, but the lights are off. Linear equations. Okay, so if you write this down, this is what we're going to have a look at first.
Do we usually have to print our own paper?
Now, all of these are on Moodle, so you can use your phone or tablet in class. If you want me to print it, just come to the office and I can print it for you. That's not a problem. Yeah. So if you want printed copies, no problem, see me in the office. If you want to use your phone, the reason is, what I used to do is I used to print these and I put them in a book, and then the students would tear the pages out, so they only have to take one page in per day, because they're like, oh, it's so heavy, I have to carry it. So I thought, I'll just put them on the internet. So if you don't want to carry it to school, then you can use your phone or tablet. But if you want it printed, come see me in the office and I can print it for you. Okay?
Okay.
Yeah. So equation of the line is first. Okay, so write this down. We'll have a look at this. So our first chapter for maths will be basic algebra. Linear equations, quadratic equations, cubic equations. I'm sure some of you have heard these words before, linear, quadratic and cubic. If not, don't worry. Today we're going to start with linear. So linear means straight line. Okay. Okay, did you write that title down? We have this? Yeah. Well, it doesn't matter because it's on the page I'm going to give you anyways. Right, so again, like I said, we'll start off with some basic ideas and basic words as well. So you've all seen this graph before, haven't you? But what is it called? What's this one called? Very good, Cartesian graph. Yep, or XY graph or something like that. Okay, and this part, this line here, what's that called? That's the X one and that's the Y. Please don't mix them up. Right, X-axis, Y-axis. And I'm sure you all remember your middle school teacher showing you how these work. So here is positive 1, 2, 3 and positive 1, 2, 3. So for example, my first point I'll put here, this is the point 2, 1 here. This is the x value, and this one, of course, is the y value, and this is called a point. Or there's another name for it as well. Anyone else? Coordinate, yeah. I'll write all these words down, don't worry. Another name for it is a coordinate. I'll nearly never say that. I'll always call it a point. Okay. And yes, what the name of this graph, we were saying, I think I have it in your first question, yeah. Cartesian graph. So really I'm just trying to make sure that you all know the basic words so far, but I think everyone's English in this room is pretty good, so you probably know these words already. If not, that's okay. That's okay. Okay, so here's a question actually. When I drew this, I made the distance here the same as the distance here, like 1 unit on the x, the same as 1 unit on the y. Do I always need to do that? Is it necessary or not? Yeah?
I think so.
It's a great question, because half the people will say yes, it's necessary, and half will say it's not necessary. Does anyone feel confident about their answer? No? Okay. What do you think? Necessary or not necessary?
I don't think the ones on the y and on the x have to be.
That's it, and you're confident about this, and you will be right. So the x and the y, they don't need to be the same scale on both. What is important though is that you keep the same scale on each one separately. So if this is 1 unit, then it must stay as 1 unit on the x, and if that's 1 unit, it must stay as 1 unit on the y. You definitely cannot change the unit size. Okay, but they don't need to be the same. This is useful to remember when you're drawing graphs and you run out of space. You can change the scale on one of the axes. Okay? Alright, most important is the words. Did you write those words down? So we have Cartesian graph, coordinate, point, x-axis and y-axis. They're the key words here. If you need to move closer, that's fine. Go ahead. There's a completely empty first row over there. Okay, continue. You have that? Yeah. Yes. Okay. Right, now, so our first sort of formula. We have 2 points, x1 and y1 is here, and then this point, x2 and y2. And this point here, does anyone know its name? Midpoint, yeah. So now the big question, this is called the midpoint because it's in the middle of x1 and x1, y1, x2, y2. Does anybody remember from middle school or high school the formula for this? You think you do? Yeah, go on, what is it?
x2 plus x1.
Yeah, that's it, yeah.
y2 plus y1.
That's it. x1 plus x2 over 2 and y1 plus y2 over 2. So this is the formula to find the middle point, the midpoint. So this is like our first formula. And this is for the midpoint. Actually, I have an idea. Maybe I can get it to work. No. Nope. Even this one doesn't fit. Because this is like a micro HDMI or something. Okay. Right. Let's just do a very, very simple example of this one here, just to get started. Do you have this formula? Yeah. So, for example, this is our first example. Let's just say this is the point 1, 1. This is the point, I don't know, 5, 5. And we want to get the point that's in the middle. So if we add the x's together, we get 6, and divide by 2, that's 3. Add the y's together, we get 6, divide by 2, and we get 3 then. So that's the middle point. What about if we had 3 points, for example? Let me just, can I scroll down? Yeah. Okay. So for example, if we had 3 points, let's say x1, y1, x2, y2, and then what the x1, y1, x2, y2, x3, y3, and we can still get a point in the middle. But what do you think the formula is now? Divide by 3. But the idea is still the same. x1 plus x2 plus x3 divided by 3. So we can think of the midpoint kind of like an average. Do you know this word? Like it's almost like it's the average point. So it works if you have 3, 4, 5 points, whatever.
So it's like x plus x plus x
Yeah,
plus
yeah.
3 times y.
Yeah. So, you know, if there was 4 points, it'd be the 4x's divided by 4. Yeah. Yeah, okay, let's have a look at what's next now. Okay, can I scroll down? You don't really need to know about this. I was just showing you this because it's nice to think of the midpoint as being an average point. It's a useful way to think about it, not just as a point in the middle. Okay. So well, unless you were American educated, it's going to be one of these for you. So we recognize what this is. This is an equation of a line. Yeah. Are most people using C, or are a lot of people here using B?
I use C.
Kind of half and half? Yeah. The people who use B, who are you? Yeah. American educated? Yeah, the Americans use B. So we use C here in the UK and Ireland, okay? So just remember that when I'm writing this down, that it's C.
So equation of the line, right?
Equation of the line, yeah. Well, you tell me, which is it, B or C? Yes?
We use
B? Okay.
B is the one all
I forgot. Hey! I should say only English in my class, otherwise. Okay. Only English in my class, otherwise get out. No. I just want you to nod.
Yeah.
It's okay. Right. So we'll continue now. So that's the equation of the line, but the two parts of it that's interesting to us, they each have a name. So this M has a name and this C has a name. And again, maybe you remember this from high school. Does anyone know the name of the M in the formula? The gradient, or slope is what we call it. Slope is what we say in Ireland, and the gradient, or I'll just write grad, that's what they say in the UK. Since this is a UK exam at the end of the year, comes in from Manchester, they will probably use the word gradient. But because we're in Ireland, I will say the word slope, because that's what I heard all my life, okay? So slope and gradient, you can switch between the two. And what about the C? Intercept, or yeah, the y-intercept. Now these are just the names. I'll explain what they represent in a moment. So this is called the intercept. So I'll explain each of these now. Okay. So the m is the slope of the line. So if the m is a very big number, then what type of line is that? Does anyone know? Yeah, is it going up? Is it going down? It's going up. Yeah, so if the m is positive, it means your line looks like this. If the m is negative, it means your line is going down. And if the m is 0, what does that mean? Well, both of these are straight. So what's the word we would need in English? Constant, yes, but there's another word I would like. Not flat, not stable, not constant, not straight. Begins with a H. Horizontal. Horizontal line. Yes. This is what I was looking for. Horizontal line. Yeah. That's if the m is 0. It's a horizontal line. And if the m gets bigger, what happens to the line? So for example, if I make this m bigger, does the line move up or does it move down? That's right. So as the m gets bigger, the line will point up more. And likewise here, if it becomes more negative, it will point further down. So for example, if this line had slope of 5, then maybe this one has slope of 6. That a bigger slope means it starts to point up more. Okay. Right, so that's slope. So for example, if I just had this here, at least I know for something like this, the line is pointing up. You know, it's good to know this because it's helpful to quickly draw the line if you need to for a problem. Now, what about this C, the intercept? What does that represent? Does anyone remember that one from school? That's it, yeah, where it crosses the y. So for example, if I had this line, y equals 2x plus 3, this is the C, I know it crosses the y-axis at 3. So my line, is it pointing up or is it pointing down? Pointing up, yeah. So my line would look like this, okay? So like I said, it's really good to know this so you can quickly draw the line for certain problems, okay? So C is the intercept. And since we're talking about intercept, this is called the y-intercept. Yes, before you say it, you could call this one the x-intercept, but that's not the word I want. Does anyone know the name for this point? If the line crosses here at x, what's that point called? And don't say x-intercept. Yes, I know it's x-intercept, but what's the special word for it? No? No? No, not stationary, no?
Y-axis.
No. Nope.
Zero line.
Nope. Okay. Called the root. Oh yeah. Oh, the root. Yeah, so this point is called the root.
So if it's on the y, we call it
The y-intercept, and if it's on the x, we call it the root. Yeah.
And the C is also the C is what crosses the line.
Crosses the y-axis only, yeah. Okay, well, nobody remembered that word, so definitely write that word down. What would you have said before I said root? Would you have just said x-intercept, or, yeah? That's fine.
Can it be called x-intercept?
Yes, it can, yeah. But I will always call it the root.
So, root, y-intercept, and does the y-intercept also equal to C?
Yeah, you can say the same thing, y-intercept or C, yeah. Okay, let's continue then. Right, can I scroll down? Yes. So, really, we really want our lines to be written like this, because then we can see the m and the c. So for example, if I had y equals 2x plus 3, you can clearly see what the m is, it's 2, and what the c is, it's 3. But of course, sometimes your line might be written like this. For example, 2x plus 3y plus 5 equals 0. Now that's fine, but then the problem with that is it's very hard to see what is the m and what is the c, because you can't match it up. It's not clear. So what might be a solution then to fix that problem? If I want to know the m and the c for this line, what could I do? Rearrange it. So we'll do this as an example, okay? So let me just get rid of that m and c. So here's our second example then. And in this example, I want the m and the c. So this should not be too difficult for you. I shall move the 2x and the 5 to the right. So I get 3y equals minus 2x minus 5. And then just one thing left to do. What should I do to finish this? Divide by 3 and it's finished. So everything gets divided by 3 and I get y equals minus 2 over 3x minus 5 over 3. Now I can see what the m is and what the c is. The m is minus 2 over 3 and the c is minus 5 over 3. So what I'll do to finish is I'll just draw this graph very quickly. I won't try to be accurate, just be rough. So I know that this graph is pointing down because the m is negative, and because the c is negative, I know it will be under down here. Okay, so I know it'll be down here because the c is negative, and the m is negative, so it'll be pointing down. So the graph will look, the line will look like this, pointing down. Oh, that's so ugly. Let's at least try to make it look straight. No. Yeah. No. Yeah. Alright. So that's my line here. That's the x. That's the y. And this is my line here. So it's negative c and negative slope is pointing down. Okay, so this is actually maybe a little bit of vocabulary here. Does anybody know what verb or how to describe what I just did here? So I know it's called rearranging, but does anyone know the way it might be phrased as a question? You know, here the y is not by itself, but here the y is by itself. That's it, very good. So here what you say you're doing is you make y the subject. Yes. Okay, write that down as well. It's important that you know all of these words for the first lesson because I'll just keep using them for the rest of the year. Okay, did you write that down? Make y the subject. That's what we do here. Okay. Right, next, now. So, suppose I have a line, let me just take, I don't know, something like this, for example. Plus 3. Is this line going up or going down?
Down.
Going down. So it'll look something like this. And I want to know if this point is on this line. So there's two choices. Either the point is, let's see, it's either on the line or it's not on the line. You know, it's one or the other. So how might I check if this point is on the line? Substitute it in. What's the verb for this? What are you doing here? Verb beginning with V. Now values verify, which means check. So you want to check if this point is on the line. And like you said, you just substitute it in. So how do we know if it is on the line after we substitute it in? It should be equal. And if it's not equal, then it's not on the line. So let's test it. Y is 27 and 8 is minus 3. So we get 27 equals minus, what's that, 24, is it? It looks like it's false because it's a plus 3. If it was a minus 3, then we'd be okay. But here we have 27 equals minus, oh sorry, that's a plus. So we're happy. It's on the line. Great. So the answer is true. It's on the line. And if it was false, if it was 27 equals 21, then it's not on the line. Okay. Yes?
So it's like give us an equation and we have to prove if it's true or false, right?
Prove if the point is on the line, if it's on it or not. So here I'm saying it's true, it's on the line. Okay. Now next we want to draw. I've done some very ugly graphs. In the exam that won't do. In the exam when you draw the line they want to see exactly where it crosses the x and the y. Now it's easy to know where it crosses the y-axis. That's just the value of c. But we'll need to find what the root is where it crosses the x-axis. So let's have a look at a neater graph than what I've been doing so far. Okay, can I scroll down? Looks like it, yes. Okay, so for example, we want to draw, let's say 4x plus, let's just say 8y minus 2, something like that, equals 0. Okay, if I want to know where it crosses the y-axis, what should I do?
If it crosses the line,
Yeah, if I want to know where it crosses the y-axis.
but x is 0.
Yeah, you could put x as 0, and this is the best way to do it. If you want to know where it crosses the y-axis, you make x 0 and find it there. If you want to know where it crosses the x-axis, you make y 0. Actually, just a little bit of vocabulary here. Draw is one verb. What are other verbs to mean draw? Sketch, yeah. Sketch. Anything else? That's it. Just the two. Anything else? Plot. Anything else? Anything else? Think about. Show is okay. Yeah. You could say show this on a graph, so that's okay. So I'll take show. Anything else? Maybe not prove, since it's a drawing. Not verify either. What about illustrate? Yes. And there's one more that everyone's forgetting. Graph, yes. Graph. Okay. Please note there is a very small difference between the meanings. So for example, draw and sketch and show, they're more informal, so the graph can be kind of rough. But in an exam, if you see something like plot or graph, they want it done more carefully, more to be neater. Okay, so what I've been doing so far is sketch, just quick graph. But for this, we want to plot it to be more accurate. Okay, so as we were saying, we should find out where it crosses the y-axis. So first we say let x equal 0, and then we'll get 0 plus 8y minus 2 equals 0. So y equals 2 over 8. So that's 1 over 4. And then the second point is let y equals 0. So we'll get 4x plus 0 minus 2 equals 0. So x equals 2 over 4, which is a half. Yeah. Okay, so write this down and then we'll make a beautiful graph. Okay, did you write that down? Yeah. Now you have to be careful, the x and the y is very small, so we shouldn't go up in 1 unit, that will be too big. Maybe we should go up in like quarter units, 1 quarter, a half, 3 quarters, 1, 1 and a quarter, 1 and a half, 1 and 3 quarters. I think that's what I'll do. So anyways, my first point is, where's my pen gone? Here. Come back. Let's reboot the pen. We're back. Okay, so our first point is 0 and a quarter, and our second point is a half and 0. Did you write those 2 points down? Yeah? Okay. Right, so let's draw the graph now. Let's try and make it neat. Great. So this is 0. We'll make this one here. We'll go a quarter, a half, 3 quarters, 1. Quarter, a half, 3 quarters, minus 1. Not too bad. A quarter, a half, 3 quarters, 1. Quarter, a half, 3 quarters, minus 1. What was my first point? 0 quarter, was it?
0 quarter.
0, so go out 0 and go up a quarter, that's here. And my second point was a half 0?
0
Yeah,
half.
0 half. So there's my 2 points. Close enough. Yeah, that will definitely do. Right, so in the exam what they want to see is the labels as well. So here you would write a half, 0, and here you would write 0, a quarter. Okay, so if your graph looked like that in the exam, then that's fine, that's full marks. No, actually that is not full marks. What did I forget? Very good, yeah. X and Y. That will cost you exactly 1 mark in the exam if you forgot that. The scale is okay, as long as the scale, doesn't change, it's okay, yeah.
Scale?
Yeah, as in like how big each step is. Yeah. Okay. Yeah, you don't need to write it on the graph, it's okay. Right, there's just a couple of more small things to do, and then we'll finish very, very, very soon, okay? Can I scroll down? Yeah. So the next thing is, if I give you 2 points, how do you find the line? So for example, if I give you the point, I don't know, I'll just pick an example here, 1 minus 4 and 2, 6. How do you find the line that joins these 2 points? Well, there is a way to do it by using a formula. There's a formula for the I wonder if anyone knows it. Yeah, what is it? Y
2 minus y1.
2 minus y1 over x2 minus x1.
To
Yeah.
find the slope.
To find the slope. So in this example, it would be 6 minus 4 over 2 minus 1. What is this? 10. Great, I have the m. How about the c though? Anyone know how to get the c if you're doing it this way?
Find the rest of the equation and then find the c and then put it back.
Yeah, it's a substitution. So for example, we know the m is 10. Y equals 10x plus c.
Choose any one.
Choose any point. We know that this point is on the line, so when we sub it in, it's true. That's what we were saying earlier. So I won't put that one in. Why not? Nobody likes minus numbers, so we'll put this one in. Doesn't matter which one. 6 equals 20 plus c, so c equals minus 14. Isn't it? Yeah. So the answer is y equals 10x minus 14. That's the equation of the line that joins these 2 points. Again, I'm hoping that this all seems familiar to you. If not, you can watch the video again later.
Video?
Yeah, it's been recorded. Yes. Okay, so just 2 small things left to show you. Can I scroll down? Yeah. Sometimes I don't give you the point. Sometimes I just give you a graph and say find the equation of the line. So you have to read the points from the graph. What would be the easiest points to read and use? The intercepts, yeah. So for example, if this looked like a 3 and this looked like a -4, what points would you use? What would be the first point to use? -4, 0, yeah, and 0, 3. And then you just do it like this, like I just did it there. Okay, so again, there's nothing crazy here. The crazy stuff comes later. Okay, so the last thing to talk about is then horizontal lines and then vertical lines. So for example, I'll just do one of each. I have a horizontal line here in red. Does it show up as red? Kind of does. And let's say there's this point on the line, I don't know, we'll call it 4, 1 for example. Horizontal lines are special. Does anyone know the equation of this line? The equation of this line I drew.
M equals 0.
True, m equals 0, but what's the equation of the line though? Y equals 1. Because when you look at this line, everywhere on this line, the y is 1. That's what makes this line special. Likewise, if I drew a vertical line here, and I called this point 5 minus 2, what would be the equation of this vertical line? X equals 5, because everywhere on this line, we're 5 units out. So when you have a horizontal and vertical line, it's very quick to write the equation down. When you have a vertical line, when you have a horizontal line, you look at the y, and when you have a vertical line, you look at the x. So it's kind of odd, because it's kind of backwards to what you might think. Horizontal line, you look at the y, and a vertical line, you look at the x. Yeah? But it wouldn't be maths if it was straightforward, and you know that by now. Okay. So what I'll do is I'll give you the worksheet and your homework. When's our next maths class? Is it tomorrow? Yeah, is it in this room or a different room?
Yes, tomorrow.
Tomorrow?
Tomorrow this room.
Yes. Okay. Okay. I'll check the homework tomorrow, but like I said, it's your choice if you want to succeed or fail. People usually make this choice, just so you know, people usually make this choice in week number 2. This is when people decide if they want to succeed or fail. In the first week, everybody wants to succeed, but then by the end of the first week, people realize, oh, I'll need to work hard if I want to succeed, and then maybe in week 2 they decide they want to fail. Okay? So I'll be checking the homework for the first 2 weeks to see what decision you make. Please choose wisely. Okay, so your homework is I want you to do A and B in each question. Okay, so like 1A, 1B, 2A, 2B, A and B in each question. As soon as you have the worksheet, you can go. If your Moodle account doesn't work, send me an email, tell me, or just send me an email and I'll reply and we'll try and fix it, okay? Usually what happens is the email address is slightly wrong and then I have to fix it. It's usually something small like that. You'll get used to the accent.
Yeah, I just want to ask you one
Yeah.
question. When you said y has to be the subject, what does it mean by that?
It means make y by itself on one side. So you have y equals whatever. Yes, this is the normal thing to do.
And x is always for the y-axis and y is always for the x-axis. When we try to find...
No. Usually we just rewrite the equation so it's y equals whatever. We like to have y by itself on one side. We don't usually put x by itself on one side. So usually we only make y the subject, never x the subject.
I know,
Yeah.
but over here, that's what I mean.
One sec, yeah.
That's x equals y.
Oh, yes. So you make x equals 0 when you want the y, and you make y equals 0 when you want the x. Yeah.
So you want...
Oh, she's gone now. It's like 4:30. Yeah.
So you want one,
I think so. She's in at 8 though. Yeah, 1A, 1B, 2A, 2B, etc. A and B in each.
not C and D and
No, that's just extra if you want to do it.
Well, we the biology says he will correct us if we did extra. Will you do the same?
Correct it?
Yeah.
Oh no, because you have the answers on the back, so you can correct them yourself. Yeah, if you flip it over, there's the answers. Yes.